Good morning and welcome back. It's a Sunday morning, can be a little lethargic, but we are here, a lot of you are here, and we are going to do this training today. Why? Because we have decided we're going to upskill ourselves. We're going to use this weekend to learn something new. This is Sanket Sarang again. I'm one of the founders of Blobcity. I'm also the chief of products. If you've registered on the Blobcity AI Cloud, you would have received an email from me. I would love to hear your feedback on the initiatives we're doing, and so please do keep sending the messages in. I usually make it a point to reply to almost all emails that get sent to me. So I hope you've had a lovely Saturday evening. Me personally, I have been at home, so the only thing I did yesterday was watch Netflix after the training. Not much, maybe cook some food and watch Netflix, and that's about it. I hope you've had something better to do than get stuck in front of your televisions. So let's get started today. I want to conduct a poll once again. So we did this last week, but we have quite a few attendees, who are new this week. So I want to quickly check, what your opinion is on, for this. So you might see a poll now on your screen, and the question is, are we helping you achieve your upskilling initiatives? And you want to know whether we are helping you achieve your upskilling initiatives. So you can quickly answer the poll. I think the question is more around what do you want to do, right? So are you trying to be a data scientist? Do you want to just be a data science project manager? So based on that, has this training really helped you, in achieving any of these initiatives, right? And that's what we want to understand. And we would love to hear, personal feedback from all of you. So towards the end of the session, you will all get a feedback form. Please do fill it up. Please fill it up at the end of each and every session, because it really allows us to go back and learn on how you find the training and improve upon from there. Okay, so 74% of you have already voted. For all of those who have not voted, want to cast the vote, now is the time. Let's make this 100% votes. Okay, 76%, 78% have voted. 80%, 81%. The remaining 19%, how about you all? You want to vote? Okay, we'll give it 5 more seconds. We'll be closing the poll in 5, 4, 3, 2, 1, and we are closing it. Okay, so let's look at the results, right? So it's interesting result this time. And yes, so what we can see is there's 89% of you who say, yes, we're definitely helping you achieve your upskilling initiatives. Around 8% that say not sure, and 3% say no. If I remember this correctly, last time it was 91% as yes, and 9% as not sure, and there was 0% for the no. So I can see that things have changed right now. So some of you have gone from not sure to no, some of you have gone from the yes to the no. So we want to really understand on what we can do better to help you achieve these upskilling initiatives. So please do write to us. We are very committed to improving these trainings and helping you out in any way we can. We do understand we cannot help all of you, right? So some of you might not, the content that we're giving might not align with some of your personal objectives. But we would like to understand, what your personal objectives are and then improve upon there. So, but I'm really humbled by the fact that for 89% of you, we are actually helping you out achieve your upskilling initiatives, and that's really good feedback to us, which kind of motivates us to keep doing this and keep doing this further. And I really hope that all of you kind of get a good sense of data science. So I do know that some of you might not find this as the right field for you. After the training, you might want to drop out. You might want to look at other career options. That's good. There's no problem at all, right? So there are a lot of career options available. If we have even helped you come to the decision that data science is not for you, I would look at that as a significant help from our side, right? So not knowing that you don't want to do something is equally important as knowing what you want to do, and we look at it from that perspective. So I really hope all of you are getting good quality content. Our trainers are fantastic. They do trainings for a lot of corporates. They charge a lot of money when they do these trainings. So we're giving them to you. Some of the, like this session is free. It also comes in the 999 offer, which is a Become a Data Scientist offer. If you were to take trainings from other institutes which are live, it would at least cost you 80,000 rupees. For something similar, which we are giving it to you at a massive discount of 999 rupees. And the only reason we're doing this is because Blobcity is primarily in the enterprise business. We are not an educational company. We are a tech company. We work with a lot of enterprises to help them on their data science initiatives. We have our own AI cloud, which is used by several enterprises to run their data science notebooks. So a primary stream of revenue is not trainings. We do a lot of other things other than trainings. And when it comes to trainings, we really believe that we want to help everyone upskill themselves. So we want to deliver the best education at the most affordable rate possible. And we want to cater to the masses to kind of make sure that everyone has an equal chance to learn data science and an equal chance to become a data scientist. So please keep those feedback coming in. This is really humbling to know that for 89% of you, we've actually helped you achieve your upskilling initiatives. This is not the first and the last training. There are a lot of more trainings to follow. Do stick with us, and you will be surprised with the kind of content we can give you. So without further ado, let's get to the main part of the presentation today. Suveer will be conducting a lot of important topics in machine learning. These are extremely crucial to learn if you want to become a data scientist. So I'll hand it over to Suveer to take it from here. So Suveer, over to you.
All right, sure. Thank you, Sanket, for this overview. And I hope this Sunday morning is going really well for everyone. Thank you guys for joining this session on a Sunday morning. Really feel happy that people are joining back. That too on a Sunday morning. So I hope you are quite comfortable now with the data science part which we are learning. So this class is basically for Python machine learning, and we're going to look at some parts today which we haven't looked before. Okay, so but before we go on to the new topics for today, a short quick recap on what we had done before. We've been talking about classification techniques all these whiles. And today also, I will demonstrate two examples, one on classification and one on unsupervised machine learning. Now, I would have to actually, apologize for, for this short time which we have. So in next 2 hours, my agenda basically is to demonstrate one of the classification techniques like support vector machines. And people are quite interested to know some practical aspects of that, like like classifying images using support vector machines. The images could be the facial images of public figures that we are going to do. One hiccup in support vector machine is that it just like any other algorithm, support vector machine also has got a load of theoretical studies before we actually take a deep dive. Now, as I said, that if I try to take up the theoretical part today, then the practical aspects would just, would not be completed. So I have just taken the practical aspects of SVM today. So we will write basic program and advanced program using SVM. We'll try to create a classifier to basically give us the predicted output using the SVM. When, as far as the science part of SVM is concerned, moving forward, if you are joining future sessions, then probably perhaps I might cover the science which we have for the SVM. But still, looking at the SVM, you'll still get a fair idea of what we are talking about. So guys, there is a small quiz. If you see on the screen, my apologies for just writing it, just like this on a notepad and not putting it on a slide. But I hope it's quite, you can still quite see this over this on this notepad. Okay, so let's start with this. And again, I welcome you guys. For people, those who are not able to access the notebook, please. You can import tool. You can also log on to cloud.blobcity.com, and you can register and start using the notebooks. Now, let me tell you one thing. Prior to working with Blobcity, I used to set up the Anaconda environment on my PC. And every time when I deliver the training, every time I had to boot up the Anaconda navigator, and I had to really use the Jupyter notebook on my local machine. So when I got this cloud.blobcity, in fact, that has really eased my work. I can anytime log on to cloud.blobcity, can access my Jupyter notebooks, which I have worked. Plus, I can share these notebooks with people who are wanting to look at what I have designed. Okay, so highly recommend it. Please go and register in case if you have not. If you're working locally on a PyCharm or maybe any other IDEs, I would recommend you to quickly switch it to the Jupyter Notebooks by Blobcity. So yes, good morning. I'm looking at the chat now. So good morning, Bhavnish. Good morning, Ronak, Siska. Kriti, good morning, Pritam, good morning, Bhavnish, Nagesh, good morning, Nagesh, Lugi, yes, good morning, yes, Sujit, good morning, yes, definitely, Komal Parab, yes, good morning, thank you, Ridu, thank you, PT Philip, good morning, Luigi. So we have a lot of people, Mridu Sharma, Pratibha, Shubham Kumar, Nisha, Sandeep, Vinayak Shukla, a lot of people, Sandeep Saha, Wet Hiswar, Anand, Kritika, Bhuvan, Muhammad Hafiz, Vanshika, Shreyansh, Vinayak Shukla, Deepa Verma. Thank you guys for joining and making this session very lively by you joining this session. Okay, so let's get started. This quiz is for people, those who have attended the previous session. In case for people, those who have not attended the previous session, still this would give you some of the other, some of the other way of understanding things. So let's go with the first question. Okay, so logistic model is basically used to model the dash of a certain class. So as you know, that logistic models, we are using logistic for binary logistic regression. It could be logistic model is used to model the dash of a certain class. Is it a sigmoid function or is it a categorical or classifier? So Ritu Jain says probability. So logistic model is used to model the probability of a certain class. That is correct. So if you look at the logistic regression, which we had done yesterday on the scores which we had, and then we wanted to actually create, sorry, not the score, the number of hours a person is putting into for studying, and then, getting in the 0 and 1, maybe yes, true or false. Arun says label of a certain class. Label of a certain class, not really, Arun, because that's fine. With supervised machine learning, we're using for labels, but this question, logistic model is used to model the probability of a certain class. So the probability has to be between 0 and 1. So what you have written about sigmoid function is helping just to compress the continuous values between 0 and 1. And once the value fits between 0 and 1, using a threshold, we can decide whether it could be a pass or it could be a fail. Okay, let's go to the second question. Logistic regression uses a dash function to model the binary dependent variables. Now this time, yes. Now this time it is a sigmoid function. So, and it is basically initiated by logit. That's right. So Arvind is saying a logit function. It's not logit, it's logit, and sigmoid. That's correct. So yes, TF-ID vectorizer transforms text to feature vectors, that is converts each token or word to feature index in the matrix. True or false? Okay, so everyone is saying true because I think the answer is already there. Answer is given. That is correct. So, so the thing is, but that's fine. But I want you to understand, what does a TF-ID vectorizer actually do? It transforms the text to feature vectors, converts each token. So that means if we have a sentence with 3 words, then it's going to convert those words to feature indices in the matrix. Give weights. That's correct. The fourth question is, Gaussian name base is based on normal distribution. So a normal distribution is a type of continuous probability distribution. Is this correct? Are you sure it's true? Just because I've written the answer over there, it could possibly be false as well. Maybe I have written wrong answers over there. So Gaussian name base is actually a normal distribution, and a normal distribution is a type of continuous probability distribution. So everyone is writing true, and the correct answer is actually true, because we are talking about normal continuous distribution when we're talking about Gaussian name base. That's why, you know, when we had a problem for the height, the weight, and the foot size, and then whether we would like to classify based on male or female, we had used the Gaussian name base algorithm because our independent variables were all continuous. Pranav says, please explain Gaussian once again. Pranav, definitely you can. I mean, right now, there's really a time constraint. I cannot go back and look at the Gaussian part because I have to come and finish the other ones. Definitely, you know, you can email it to the support. We can interact over the support email, or you can join the subsequent classes in the next weekend. Okay, so all right, so we're done with 4 questions. Let's go with in pandas. Now I've added some bit of a pandas question as well. So in pandas, what I'm saying, when we define data.drop, so the first argument is going to be a column, and the second argument is going to be access. So what the arguments expect over there? I've given you all the hint. So Kriti says, yeah, feature names. The Arun says column. That's correct. So in the example of iris, could you tell me, so if I want to fit iris here, how would I write the statement? Column name and access is equal to column. So, so column is basically, is it a name or it's an index? Or access is basically a name or it's an index? Ayush says access 0 or 1. Nisha says column name and access 0, 1. Column is index. Are you sure, Nagesh? Column is index. Tejas says index. Column is equal to feature. Kushbu says column is equal to feature, which is actually correct. And access is either 0 for rows and 1 for columns. So that is correct. So if I want to write this in context with iris, if I want to drop, let's say, species, because species being a categorical variable, and access is equal to 1. Okay, so I'm going to write the statement in this way for iris data set. So if I want to drop the categorical column and load only the continuous variables, no, Wasim, if you skip the access, it will not work, because this is the pandas that drop functionality, which expects if you're dropping a column, then specify access as 1, and if you're dropping a row, then you specify access as 0. Okay, moving to the next one. Logistic function is defined as 1 upon 1 plus exponent of negative t, where t is an equation of straight line. Is this false or true? Kunal says true, Wasim says false, Nisha says true, A lot of people say it's true, so this has to be true. So that is correct. So that is right. So basically, logistic function is defined as 1 upon 1 plus e negative a plus bx. And what is a plus bx? So here we're going to fit actually our coefficients and the intercept equation. And the negate of that going to be added with the plus and then divided by 1. So this is going to give us, actually a sigmoid, a logistic function which compresses the value between 0 and 1, between 0 and 1. That is correct. So we are converting to linear. A Gaussian-Nebe model required 2 parameters, mean and variance. Is this true or false? That's great. A lot of people are saying true. That's great. Fishbu, Ronak, that's very nice. Definitely. So when we are looking at Gaussian name base, we saw that we actually took out 2 parameters. One was the mean and the other one was the variance. Okay, so definitely it is true. Confusion matrix is defined between the independent and the dependent variable. So false. So everyone is saying false. So it's actually between the actuals and the predicted. Okay, so the answer is actually false here. True and predicted, Himanshu, that's correct. Answer is there. Yes, accuracy score and confusion matrix both fall under the metric class of sklearn. Are you sure? Okay. Okay, that's right. So when we go with the accuracy score identification or confusion matrix, then it comes into the class of metric in sklearn. Okay, so that's what we've been seeing all these whiles. Okay, so let's go and jump to today's topic, which is basically an SVM. So as I said, that SVM is also a very successful technique for classification. And basically, it's a support vector machine which works on hyperplane parameters. Now, if I try explaining the hyperplane parameters and a bit of the science behind that, then probably, our 1.5 hour is going to go in that, and we will not look at the syntax of SVM. So what I'm looking for is to basically demonstrate you the syntax first, how we are implementing SVM in Python, and then we can talk about other theoretical aspects which are needed to understand SVM. Now, mind it, what we are doing today is we are writing the codes, but this is not the best way of learning SVM. Actually, it should start with hyperplane modeling or hyperplane selections, and then we should go for a demonstration. But since, as I said, post our break, that is post lunch, I also have to demonstrate, unsupervised machine learning, which we haven't seen even a bit in our sessions. Okay, so we also have to touch base k-means plus string or any other example on unsupervised. Okay, so this is my new notebook for today, and I'm going to mark that as day 4. Okay, and most of the things which we're going to do today is basically going to be from the same way what we've been doing before. The steps which we've been doing before, like creating pipelines. Pipeline is something which I haven't explained it to you, but I will try to do that today if possible. Regularization, I haven't touched into at all, which is an important topic again in classification. So a couple of these things, and of course, not touched about making pipelines. I have just shown you how to make the pipeline. No, Ritu, you basically create a new notebook, and you can name that notebook anything. Could be a day 4, week 2. Yeah. Okay. Wasim saying gradient descent. That's correct, Wasim. Actually, the thing is, I have some plans for today, so let's see how far we are able to do. Can we create pipeline for any model? That's question by Kunal. That is actually correct. So we have to create pipelines. We can create pipelines for any model using sklearn. Actually, pipeline is a feature in sklearn and not typically for classification. Okay, but we need to understand what is SVM first, okay, and what basically support virtual machines do. So let's say I would want to write some text here. The SVM basically stands for people who are very new, stands for support vector machines. Okay. Now, support vector machines, why it is called as a support vector machines? Because it purely works on hyperplane modeling. I will explain that moving forward. So, the SVM classifiers. So let's say, so we have SVM classifiers is actually gives good accuracy. Okay, it is very good in the accuracy, and it is much faster in prediction compared to naive Bayes. Okay, initially we had done naive Bayes. So SVM classifiers are actually good, gives us good accuracy and much faster than prediction compared to naive Bayes. It also help optimize the memory consumption, the memory usage for that matter. Okay, now it's also good in case if you're looking um, for the training, for training the model, that's where the main usage of memory actually happens. So in case if you're learning artificial intelligence and if you're training, a cognitive model, then if you have an 11 GB or any kind of a graphics GPU with you, then that's going to really consume a lot of memory, probably, 10 GB in just one shot over there. So if we are trying to do something in SVM using an artificial intelligence, then, definitely SVM is going to help us over there. Why it uses less memory? I mean, any specific reason for this? Yes, it uses less memory because it uses a subset of training data. Okay, training data points basically. Now, subset of training data point means it's just going to take out some part of the training data which we have over there and just try to work on that. And SVM basically works on margin of separation. So you can just say hyperplane margin separation. Okay, so what this exactly is, hyperplane margin separation, this is all the science behind what we have. Okay. Um, so yes, so what are we going to do is we're going to use SVM, and using SVM, we're going to try to find out some classification, some way to classify some set of data which we have with us. Okay, so what is the example I'm going to use? I'm going to use a face recognition using SVM. Now, if you could recall, or in our previous session, we had done something with the images. I think it was handwritten digits, right? So we had imported handwritten digits from the existing data set which we have in sklearn. Um, and then we tried to actually take uh, points as training set. So could anyone answer on the chat that when we loaded that digits data set, what did we consider as features? So as you know that definitely for training we need features. So in the digits data set, handwritten digit data set, what did we use as features? Any inputs? So Sunkara Nagendra says we had used pixels as feature vectors, which is actually correct. So we had an 8 by 8 image over there, which basically gave us 8 by 8 image over there, which basically gave us 64 pixels image, okay? Because 8 into 8 is 64. Similarly, just like 8 by 8 pixel image, we will import some image over here and we'll first try to check the shape of that image. And it's going to be more than 8 by 8 for sure, okay? So We'll also see how many records do we have for our image data set. So let's go ahead and get started. So in order to get the images and to look how the image actually looks, we have to go and from sklearn dot, probably you can help me write this in Texas. So from sklearn dot, I want to import the data set. So what I'm going to write is from sklearn dot, what is the class which I'm going to use? That is correct. So data sets import. Okay, this probably I might help you out with. So fetch. Okay, now we had used fetch 20 news groups, if you see, yesterday, but instead of 20 news groups, I'm going to fetch LFW people. Okay. So from sklearn.datasets import fetch LFW people. Yeah. Okay. So this is basically the data set, and I'm going to create a variable called as a face because I'm going to load the faces. Now the data set is actually infinite. It's got a lot of records in that. So I'm going to just pick up a few of them. So I'm going to say you load this, people data set into a variable called as face, and my argument to this is going to be minimum faces per person is, let's say, whatever, I'm going to say 20 or something like that. Okay. And then let's say print me, you give me the target names and you give me the shape of the images. So what syntax would I write here if I want to get the target names in the data and if I want to get the shape in the data set? So what do you think I should be writing here? Print what in order to get the target names? I hope the concept of target names and the data is quite clear, okay? Because we are using the inbuilt data sets. So inbuilt data sets, they are already segregated, as I said yesterday. It's already segregated by the targets and the data, okay? So what do you think I would be writing here? I want to get some data. So faces dot target underscore names. That is correct. So I'm going to say face. I'm going to use a tab key. So the tab key is not working because the face is not loaded. So target underscore names. Okay, because this way I'm going to get the target names. And the other one is I have uh, instead of the data, we have the image. So even in the 20 news groups, sorry, the handwritten digits, we had data in the image part. And I want actually the shape of this image to be loaded. So when I actually run this, okay. So Wasim, you're right. You had written dot data. You're actually right. But the thing is, uh, you know, the data is not available in the image, so we have the face or the variable dot image and not the data. The data would be there if you're using any continuous textual data over there. So print face dot image. So this is not working. So see, so this is a typo. Okay, so actually it's face dot not image. It's actually images. So let me just go face dot I, and since the face is already there, okay, no problem. Images. Okay, so this is running for me. Now, if you see, I've got around 3,023 records in this data set. And what is the 62 and 47? So 62 and 47 is basically the the pixel dimensions to that. So if I'm basically doing 62 into 47, that's going to give me around 2914 records. So you can just consider as around 3,000 pixels. This particular, this 3,000 pixels, we have this data set. And these are like a couple of names. If you see out here, just, so all the famous personalities like Kofi Annan or Laura Bush, or maybe like, you know, Bill Clinton. I'm not sure if Bill Clinton is this. So we have, the Vajpayee, we have the Carlos, Colin Powell is there, George Robertson, George Bush is there. So David Beckham is there. So a lot of famous personalities. John Ashcroft is there, Michael Bloomberg. A lot of people are there. So what is there? These are basically just the names or the labels to this. So now this labels is already given to us with some kind of an images on that. So our work is now basically to classify based on, to basically get the labels based on new input data. Okay. So Pranav says, in reality, every pic can have different dimensions. Is this 6247 for all images? Yes, that is correct. So Abhijit says, getting error while executing the second line, please show what is stored in face. Okay, so if you go, see, actually, face is just a variable in which we have loaded the entire set of these famous people, okay, with some kind of a thresholding about minimum faces per person argument over there. But actually, face is a huge set over that. We have to extract certain classes from this face, like the one of the classes target names, and the other class is images. So let's go and try to find out. So as you're saying that you would like to see what we have in these in this phase over here. So let's go and try to see what do we have in the data we have in this phase. So Ritu says is 64 by the pixel dimension of each image. Yes, that is correct, Ritu. Are there functions pandas Kitlan to create images of same dimensions? I didn't get it. You mean the image to create images of same pixels or same dimensions? Saptashri, what does min faces per person determine? So see, Saptashri, this data set which we have for faces in the sklearn, that is what we're using is fetch LFW people. It has got records of many different famous personalities. And if you see, there are actually repeat personalities in the data set. So maybe the George Bush has repeated maybe 20, 30, or 60 odd times with different faces, with different facial expressions, etc. So what we're doing here is we are saying that you limit per person to 20 or 60. Yes, definitely, Kshitij, but I mean, I can definitely show you how to create your own data sets, but I would recommend first to practice on the existing data sets. I'll definitely share the syntax, or you can Google about creating your own data sets and putting it into a library. So you'll have to get in touch with sklearn to do that. Can we display the images? Yes, I'm going to do that in my second code. Can use our images. Yes, you can use your own images. I'm getting as notepad, where can I get this data set? So Rahul, this data set is basically used from sklearn, so you can import it directly from the sklearn, just like this, the way I've done it. Okay, so we have all the data into the face. Now you could recall in our second session where we were actually doing the handwritten digits, okay? So handwritten digits, when I was explaining, I had written some kind of a plotting code over there. I'm going to write the same plotting code, and I'm sure people might have questions on that plotting code. But right now, we can just relax and just look at it, how basically we are able to render the images. And we can discuss about the coding part as we move forward. So just like before, I'm going to create two variables. One is going to be my figure, and other is going to be my So I'm going to say plt.subplot. So, I have not imported any libraries. So definitely insert cell above, import matplotlib dot. So what do we have? So matplotlib.pyplot, import matplotlib.pyplot as plt. Okay, and I have imported the plot, and let's see if I'm able to get some options. So plt dot, definitely we have. So in fact, I want subplots. So uh, I want a lot of plots within the plot. So I'm saying that you create a subplot, and the subplot should have 3 rows and 5 columns. I'm sorry, guys, I'm actually getting into the syntax of Python, but this is something which is needed. I can not simply copy and paste and expect you to understand. So plt.subplot, you give me a grid wherein I can actually fit 3 images into 3 rows and another 5 images into 5 rows. Okay, and I'm going to use the for loop. For I in basically. So I'm going to use, let's say, AXI instead of AX in. So you could say enumerate. So enumerate is nothing but iterate it over there. AX dot, you could recall that what we had used here, actually flat, because I want this, basically the axis over there to flatten up so that I'm able to render the images. Okay, so I'm going to say AXI dot I am show. I am show is basically a plotting functionality, and I'm going to say face dot images because I've got images inside that, and I'm going to use I because I is my iterator here. So for every image, you pick the image one by one, and color map is equal to, give me some color map. Um, Bookmark. Okay, I'll just use B, or basically you just give me the some B color, or maybe some white, or maybe blue. Okay, now I have done the show, so I'm actually iterating every image and trying to render it. And I can also set my xticks, or basically it's TICKS is equal to create a blank list, and yticks is also you create a blank list. This is the same code which I had written before, comma, and I want X label. Sometimes the IntelliSense won't work. X label is equal to face dot target underscore, actually target underscore names, because I want the faces names to be displayed. And what names I would like to display is face dot target, which is actually the data, and the I in that data. I'm going to close this here and close this here. Error, some kind of an error, value error. So illegal argument to subplot 3 and 5. Figure, let me check the code. AX equal to PL dot subplots. Subplots is not a subplot. So actually this is subplots, and it's 3, 5. You give me 3 rows, and then you give me 5 columns on there. What's the error now? And show CMAP is B. Okay, I'll just go with bone because that's basically the color of the bone. So yeah, so successfully I could actually render the images. So now somebody was asking that, can we see the data inside? So yes, so I have rendered this data outside in actually a plot. Now we cannot directly render this unless we actually create the data, write the code in this way. So I'm actually flattening the axis over there, and then I'm enumerating on that and showing up the different, ticks over there. This is an empty list. So basically this list, it is for this one. So these names you can see is actually for those ticks for X and Y. And then we have the labels over here. And the labels are basically iterating. See, basically the X ticks are nothing but, the data points where basically it's going to render up. So ticks are nothing but the data points which is going to be plotted on the axis over there. So this is how the data is. So we've got a lot of people: Ariel Sharon and George Robert, Bill Clinton, George Bush. So if you see, we've got images of almost, we have got repeat image also if you see. So if you see, the George Bush is here, and he's basically here as well. Okay, and any other place, not, I don't see any. So at least I can see two images for George Bush. This one, that is the third row first column, and the third row second column. So this is basically, we have more than one image of the same person out here. And since I've taken that you give, like, say, minimum faces per person is 20, so definitely we will have 20 repeat images for the same person, but definitely it will have different features in that. So if you see this particular image is actually a very strenuous image. It looks like the face is being strained, and this looks like as if the face is expressing something, or basically going to talk or speak, or already speaking basically. Okay. Flat not defined is error. Mridhu says flat not defined. Okay, let me go to the code. This is the code, guys. I would want you to, parallelly practice this code. Write it in your notepad and at least get the output. If not, I'm sure if not understood it fully, you can still at least try to, take my help on the call right now and at least get this rendered on the screen. And later on, we can take our own time to understand that part. Yeah, so that is because, so Naveen says, I don't get the names, instead just numbers under the images. That is because, you have to use X label. Can you see that's basically the X label part? So the Ami Choksi says, got the output. That's great. So names are getting overlapped. Is there a way to fix it, Kunal Pandya? So definitely you can increase the subplots. So you can increase the subplots over there. And also, set the fonts for the X label. Yeah, that's correct, Naveen. Thank you. Ritu says, got the output. Can you tell what is this X ticks, Y ticks? That's, as I said, that's basically to set the pixel ticks over there. To plot the data point, we are using those X ticks. Error in subplot as module error. So try to use subplots. I had also used subplot. Try to use subplots. Okay, Luigi says the images and the text is okay. All right, great. So we could actually see some successful and very renowned people into our database. So what we want to do is we want to now classify these data sets or these images using some classifier. Now, my question to everyone: can I use a Gaussian name-based classifier in this scenario, in this situation? Can I use a Gaussian name-based? True or false? Wasim says no. Kunal says false. Arun says yes. Tasha says false. Misha says no. So Pramod says no. Ritu says no. Okay, I got it. So I want to ask people, those who are saying no, what is the reason for no? Ronnie says we can use, but accuracy is less. Is it really? Rajiv says, is PLT used for matplotlib? Yes, Rajveer, PLT is actually we're giving in a short acronym to matplotlib. Instead of typing matplotlib as plot or scatter, we are just using PLT as an alias, as in to the matplotlib. Gaussian naive for normal distribution. So do you think this images data is not normally distributed? So you think, Ramesh, that images are not numerical data? So images are not numerical data. So how are we going to work on artificial intelligence then? How are we going to use cognitive neural networks basically to identify an image, whether it's basically whether it's a bus or it's a train or it's an aeroplane? You know, you've seen a lot of models on maybe in many places that people are classifying, or whether this is you know, a sheep or a goat or a dog or a ship or a train or a bus, right? So do you think all those images are non-numerical data? Okay, I'll just scroll a bit for where Ishwar. Okay, okay, you can have a look at the code now. We have more than two classes. So we have more than two classes. Kunal says here we have more than two classes. So Gaussian naive works on more than two classes, Kunal. I mean, absolutely, there's no problem in that. We studied yesterday Gaussian naive maybe for more than two classes, which we can use, but it should have the continuous data. And the second we had studied is binary logistic regression, wherein the independents were continuous, but the dependent were discrete. The other aspect, the multinomial logistic regression, we haven't seen today. In fact, I wanted to pull an exercise for you on you know, a binary logistic regression, wherein we wanted to predict whether a person is likely to commit a crime or not, given the gender, the population, you know, the income, and other factors based on that. So that would have created a very good example. But somehow, you know, I couldn't do that. So each image has its set of attributes, hence can be used to analyze in pixels. So yes, so Pranav says the values are in pixels, and pixels are basically numerical data. So don't you think that we can use a Gaussian naive Bayes in this case? So logistic regression is not possible because it's just for discrete categorical variable. We can probably use a multinomial logistic regression or multinomial naive Bayes over here. Where Shore says, thanks, but still I'm getting an error positional arguments. Could you just look at the code properly? Where Shore probably, and mind it, are you using the Blobcity notebook? So guys, people who are getting the error, you know, I would recommend to switch to the Blobcity code, to the Blobcity notebook, because you know the sklearn version which we have in this and any other library versions which we are using, or we all will be on the same page then. Yes, Vetishwar, if you're using a Blobcity notebook, then you should not face any issues. Could you just recheck the code again before I go and switch to the next code, before I start writing the next step? Okay. There's one part which I will just write below this code, and numpy and the array object is not callable. Rajveer Patel is writing, have used matplotlib. Matplotlib. That's correct. So you have to use, if you just say import, did you import? So you have to just say this one, import matplotlib.pyplot as PLT. And then you can go for the other, for the, let me just get rid of this text. I'll just use this scissor. So import matplotlib.pyplot as PLT, and then you have to write this code. Okay, can you retest, recheck? Rajveer says, yes, I've used it. I've used matplotlib. Wethishwar, are you able to get through? Okay, so I'll have to proceed on this. But in the last line, X label face.target names, target. Thanks, it's working now. Okay, got the output. Great, great. GNB will consume much memory than SVM. Kunal says, Gaussian based can be used, but will be consume more memory than SVM. Yes, that is correct. Which OS is better, Linux or Windows, for getting these packages installed in its own machine? So basically, Python is operating system independent. But yes, I mean, if you ask me personally, then I would recommend you to go for a Linux-based kernel, um, because of its ease of management uh, about the workspaces, the environments, the package installations. It's much more managed over there. Rohan says downloading dataset very slowly. Okay, no problem. So Rohan, you can update whether it has started to display. Chandrasekhar says got the output and code is working. Perfect. So let me proceed to move forward. But before I move forward, I wanted to ask people: have you heard about principal component analysis? Has anyone heard about principal component analysis? Ayush says yes. Okay, so Ayush, if you saying yes. Nagesh says yes. Mridul says yes. So could you just give me a very brief about Ayush says it's a feature selection. Very good. So Ronik says don't know. Saptashri, no. Okay, guys. So actually, I will not be able to spend much time on principal component analysis over here. But the idea here is that principal component analysis uses you must have heard a metric called as eigenvalues. EIGEN. It's a part of mathematics. Eigenvalues. Okay. So what does an eigenvalue do? Is basically nothing, but it is actually the more reasonable or maybe the rational number for a matrix. Okay, PCA eigenvectors. That is correct, Arvind. Now, I can explain you in a very, at a very high level. So let's say in principal component analysis, eigenvectors or eigenvalues is basically determining the component which we're looking at. So PCA, for people who are not aware, PCA is actually dropping off certain features which is not necessary for our model training. So you can say PCA is actually dimension reduction technique or a feature reduction technique when we are running the PCA for those features which are not needed into the model. Okay. So I'm going to write some PCA code, and I will not run you through what exactly that PCA did because that's the background of that. You just have to look at the code right now, and then we can discuss about it as we move forward. But PCA basically works on eigenvalues. And what are eigenvalues? So I'm sure that people will have questions. What are eigenvalues? Eigenvalues are, the reasonable or the appropriate value for a matrix. So let's say if you have a matrix with you, okay, it's a 2 by 2 matrix with some 4 elements in that. So what is the actual number for this matrix? If you simplify this a particular matrix, then what is the number for that? The number for that is going to be an eigen number or an eigenvalue, okay? Earlier also we have done that variable reduction. Nagesh, I don't remember in the code where we had used PCA. I don't think so we had used PCA anywhere in our previous codes. Rajveer says, can you share the code? I'm sorry, this code. So what I can do for people, for the code which is not working, I can actually Control A, Control C, and I can put it into the chat window, okay? Actually, I want to the entire audience, and you can take this code. So this is the first code block of code, and this is the second block of code for people those who are unable to write that. But definitely, please be sure about the indentation. So if I'm putting the code in the chat box, so when you copy it back in your notebook, indentations might just go here and there. Okay. Okay, got it. Thank you, Rajveer. Okay, let's proceed. So I spoke something about the PCA, okay, and PCA is something which is a dimension reduction technique. So in order to do that PCA, I will have to do from sklearn. And if you see from the day one, we are just sticking to sklearn. I have tried to keep things simple because sklearn is the most renowned library over there basically for machine learning. So if you see, I have not used any other library, not even stack models or anything for that matter, just to keep things simple and at least master one technique. I'm going to say from sklearn svm import svc. Okay, I'm going to tell you. So what is svc? Decomposition. I'm going to say import randomized. I want to import randomized PCA. Import randomized SVD. Okay, I think this library is changed. So it should be randomized PCA. Randomized PCA should be there. Okay, it's not there. So I'm going to say import PC. So do we PCA? Okay, as randomized. No, as randomized PCA. Okay. Let me see if this is working. I'm not too confident on this part. Okay, it works. Great. So decomposition import PCA as randomized PCA principal component analysis. And last but not the least, from sklearn dot pipelines. Actually, I want to use a pipeline and import. I like the pipeline a lot. So unfortunately, I couldn't explain much about pipelines. So from pipeline, import make pipeline. Now, this whatever code I'm going to write in this block is actually for decomposition. Okay. Decompose the images data. So guys, I just wanted to make sure that you have successfully imported these libraries and you are having no issues in importing these libraries. It's pretty easy to, it's very easy to type these libraries in Jupyter Notebook by using the IntelliSense options. So PCA is equal to, I want to create a variable called as PCA, and I want to put some kind of a randomized PCA with some components, with some random state, etc. So I had imported randomized PCA, so I'm going to say my PCA is nothing but randomized PCA. Now, what happens in the background? I'm going to say number of components is going to be, let's say 150. And what are the other? Whitening is equal to true. And then random state is equal to some random state. Okay. 42. Okay. Now I'm going to use SVC, which is actually a support vector classifier. Okay. We have SVM, support vector machine, and then we have support vector classifier. So from SVM, you import SVC, a support vector classifier, which is actually the hyperpolling selection. So I'm going to say SVC, which is actually a function. And this is where I'm going to write some kind of a kernels over there. Now this is basically an important part for us. What happens is, what is a kernel? In SVM, we have to define some kind of a kernel over there. Okay, and that kernel is basically responsible. So I'm going to talk about that if required here. So I'm going to say kernel. I want to use the kernel as RBF. I'm going to tell you what RBF is, and I want the class weight to be balanced. You just balance the weight for these guys. Okay, and CET balanced, that is correct. And then you stop here. So create two variables, PC and SVC. Let me see if this is working for me. So SVC and PCA work for me. The next step is I want to create a pipeline. So model is equal to make underscore pipeline. Okay, and make pipeline of what? Of course, of PCA and SVC. Okay, so make pipeline is not defined. So I want to Have I not imported the pipeline? Okay, maybe I had written this later on. So I have created a pipeline, which is like a principal component analysis, and then going on to my support vector classifier. So once you take, this PCA data, you do the PCA on that, and then you push this into the support vector classifier. I mean, this is basically the pipeline which I'm creating over here. Okay. So we can read it this. So in case if you've not written the code, you can simply quickly import these libraries and start writing these PCA, SVC, and the model. So 3 variables we have created. And what are the kernels available with us? So I'm using RBF. So do we have any other kernels? So RBF is, we have R radial basis function. RBF is actually radial basis function. So what exactly is that? It's actually a kernel for support vector classifier. It's basically a hyperplane, the modeling kernel over there. The class weight is balanced. We are saying that if you're classifying, then the class weight should be equal on both the sides. And once this happens, once the classification happens, you put this into SVC, and then you create a model with a pipeline of first reducing the dimensions and then fitting it into the vector classifier. So yeah, so Arun, pipeline is basically to streamline your code and letting the Python kernel know that what are the execution steps, what is basically what's going to come next in the pipeline. That's basically designed. SVC object is not callable. Nagesh is saying SVC object is not callable. So I mean, you can import the SVM, so you must have not used the SVM. PCA is actually principal component analysis. So we have got almost how many? 3,000 pixels, right? So 67, 64, what is that count? 64, where's the shape? Okay, let me run the shape. So if you run this shape, you would see that I've got almost 62 by 47 pixels, right? Now, it could be this way. Now, if you look at this image, okay, now let me explain you what PCA does at a very high level and not technically. So if you look at this particular image, you could see, what are features basically? I just want to ask one question for people who are asking about PCA. Yes, thank you, Nagesh, it's working. So what are feature selection? So if I'm saying I want to select some features from this particular character or maybe from this guy, so what do you think the features are going to be? Okay, pixel, that is correct, Wasim. So Wasim is saying the features are going to be pixel. So okay, so my question now is, so let's say this guy, okay, gene creatine, okay, now, can you see the structure of the forehead out here? Can you see the forehead of this person, and in fact, forehead of all the persons? Okay. Now this is interesting. Please hear this out. Now, when I'm going to extract the features, okay. No, it's not color combination. So when I'm going to extract the features, I'm going to extract it pixel by pixel, right? Because I've got almost 3,000 pixels, around 62 as X and 47 as Y. So I've got around 3,000 pixels, but out of these 3,000 pixels, only few pixels are important to me, right? I'll tell you why. The pixel, which is basically around the eye or the eyebrow, the pixel on the nose, the pixel on the lips, maybe on the chin, maybe on the ear, or maybe on the neck or something like that. Okay, these are the features which are important. Features which are not important, like if you look at the forehead, okay. So if I actually take this area, I hope you're able to see my pointer, my mouse pointer. So if you see this area, this pixel, and if you give this pixel or this pixel or this pixel or this another pixel, the model is cannot identify by using the forehead pixels, because most of the forehead pixels is going to be the same. So it's basically going to create a lot of noise. I'm already giving examples, Saptarshi, that where we are using the PCA. So what PCA is going to do, it's going to drop these features from our input. We are interested only in the edges. Okay, so edge means edge is basically the edge of something where I'm just going to get some inference. So let's say if I take this pixel which is near the ear, okay, can you see this pixel which is near the ear? Definitely, I'm going to get a different pixel here compared to if I take something which is near the lips. So the near the lip pixel is going to be different than near the ear pixel over there. But what if I take pixel from the forehead and then again the forehead and then again the forehead and then again the forehead? The pixel is not going to change, right? I hope you are getting what I'm saying. So, I mean, just to give you, I'm not sure if we can open up PowerPoint. Okay, let me just pull up this slide itself, the one which is already open. Okay, so let's say I want to just duplicate this slide. I'm just on a high level. Let's say insert. This particular box looks like the forehead of a person. Let's say. Okay, so this is what the forehead of the person looks like in the image. What I'm saying is, if I try to take, this area over here, if I try to take up this area, or if I try to take up, as the similar area over there, if I try to take the pixels of this area, if I try to take the pixels of, again, this particular area, do you think these three pixels have anything in common, or do you think these three pixels are different than each other? I would say that these three pixels are not different compared to each other. They are exactly the same. Let's say I'm going to take out pixel from here, which is actually the corner of the image over here. Okay, or if I'm going to take the pixel from the ear side, so there is an ear on the left or right hand side, so I'm going to take the pixel from here. So this is my unique feature. Okay, this is going to be my unique feature. This is going to be my unique feature. And similarly, if I have a nose here, so I'm going to take some pixels from my nose. If I have a nose here, I'm going to take some pixels from my nose and some pixels from my lips also. These are called as unique features in my image. So the lips is going to be there, the nose is going to be there, the ear is going to be there, here also the ear. But if you see the forehead, it makes absolutely no sense in making these three pixels as our training data or feature selections. So what PCA is going to do, PCA is going to drop these things. In fact, it's not going to consider in our feature, because if I train these three things, they are no different. They are just adding noise in the data and nothing else. But if I train using these things, these data points or these features, and the next feature which comes in, it's going to be validated, and then it's going to say that, okay, that the feature looks different, and it seems that the feature is for a nose or for a person, etc. Okay, so this is at a very high level. I gave an example of PCA, Saptarshi, and where PCAs are used. PCAs are used in machine learning. PCAs are used in artificial intelligence, just basically to reduce the training data set. Rather than reduction, the more precise word is, selecting the best features is basically the work of principal component. That's the reason it has got a name as principal component. So what are the components from this? What are the components from this particular image I should be considering for the training data set? Okay, that's basically a very high level of PCA. And what about the radial basis function and all the see, data science is a lot of things. It's just not just it's not just Python. Um, it's got a lot of things which we still have to do. So I would recommend that you keep coming to the Block City sessions. If you're arranging new sessions, then I would recommend you to keep learning, keep coming and keep learning things. Sure, Ritu, thank you. Okay, so we have created a pipeline, which is actually a model. And in this model, we have our PCA and we have our SVC. So PCA, what this randomized PCA has done, that it has taken up, only the relevant features from our image. So the next step now is basically to train this data. Let me see. I've got face.images and face.data. Okay, we have face.data also with us. So you would see that I've got face.data and I've got face.target. So let's see what is the target. Target is also an array, and what is the target names? These are the names which we have in the database with us. Okay. So face is actually a variable which we created earlier. Face is a variable which we created earlier here, and this is nothing but the database of many famous personalities. And if I want to explore this data set, so I'm going to say face.data, and if I run this, you would see that these images which you see out here, so these images, what is being there on the plot is actually given in the form of an array. And can you see these images, basically they are two-dimensional. Okay, so you will have to see that it is two-dimensional. So its arrays are basically two-dimensional. Can I have shape? Yeah, so you could see that it is two-dimensional. Okay, so what do you think? So now we have the data with us in the pipeline. We have the SVC and the PCA. What is the next step? Could you tell me what could be the possible next step for this? Now, the next step is basically to train this model. Okay, there are any other more aspects like grid search method we're going to use, which I haven't explained to you, but I'll definitely demonstrate right now. So, but before that, we need to do some model selections like training or testing and splitting the data set. So what statement should I write? From sklearn dot model selection. Okay, so model selection. Import. I want to import what? Train, test, split. Okay, what would be the next step? Can anyone tell me? Split. What would be the syntax? Split variable, that's correct. So what would be the next syntax? That's great. Xtrain, xtest, ytrain, ytest. So we're going to create 4 different variables. Okay, and then train, test, split. And what data we would like to split? What data we would like to split? What are we going to write here? Face, but face what? Face dot data. That's correct. Face, not images, data, because images are basically images, but data is actually in a ND array with us. So face dot data. And what are the targets? Target is face dot target. This is the target. And random state. Random state is 1. Okay, so let's see, what is the data set we have? Xtrain. What we can see is, can you see the shape? So you would see that Xtrain is actually 2-dimensional, which is needed for our training data set. And what do we have in ytest? Sorry, do we have a ytest? Not ytest, we need ytrain, ytrain dot shape. and you would see the white train shape. It's just one dimensional. So this is perfectly fine for our classifier. Okay, so as we know that features should be 2-dimension and target vectors should be 1-dimension. So this is absolutely okay for. Um, and a couple of things which I would want to include here. I mean, if I would have wanted, I could have skipped this part, the one which I'm trying to show right now. But I feel since I have not covered the topic, I would not be able to talk much about that right now. There is a method for cross-validation. So we did a small sample of cross-validation, right? So we had the holdout data sets examples. Then we had, the reverse examples about considering training as test as training. So we had 3 different types of cross validations over there, right? So we had seen previously. Now, there is a method in cross validation called as a grid search method. Okay, grid search method is very useful for grid search method is very useful when we're talking about images. Okay, so Control A, Control C, and take this. I'm not sure where did that code. So did you receive the code? I have pasted into the questions panel itself. So did it go to the chat? Yes, okay. I hope you've received the code. Okay, fine, Shreyansh. Okay, so target names. Actually, I just used the scissor. Gone. So ytrain.shape, we got some. Again, I use the scissor to get reading. Let's go. So we have the PCA, we have the SVC, we have the model, the pipeline basically, and we have the model selections with us. Now, what next we want to do is basically use the grid search method. And why are we using grid search method? Basically, it is a validation model validation technique. So what is the library from sklearn? And grid search basically comes in model selections. Okay, so sklearn.model selection. We have import grid search CV. Okay. So let's see what is, so grid search CV, open bracket, question mark, and the tab. Okay, it is, I've not imported that. So let me just import this, and then grid search CV. And if you see, what does a grid search CV do? It is saying you mention the estimator, and then you give me the parameter grid. Okay, now see, this is a science behind. So since we have not done the grid search, so I'll not be able to go beyond this. So what does this grid search is basically doing? If you look at the pixels, which is some pixels, let's say 4x4 or something like that, it's going to, so the grid search method is going to go to the corners of, as I mentioned in the PowerPoint, it's going to go to the corners or basically the edges over there, and going to get the relevant pixels for the model validation over there. Let's see how we're going to write this in the grid search. I'm going to say just grid, because this is going to be my grid, and I'm going to create a dictionary. I'm going to say SVC because support vector classifier, and column name is that. And let me put some values. I'm going to say you go to 1, you go to 5, and you go to 50. And so I have created a grid. And then I will also have to create the SVC margins over there. So I'm going to say SVC underscore mar, which is basically the margin. So it's a dictionary. So this is a column name, and the values for this margins, I'll just use some random. Definitely, if we use these values in a better way, our optimization is better. So I'm going to use all points, 0.001, and let's say 0.005. I'll come back to what this SVC margin. So as I said, that since this is an image, grid search CV, it's an image, I'm saying that you go to these borders, and the gamma is basically a gamma variable. You use these parameters for the gamma part, okay? And then I'm going to close this. And then I'm going to say grid, which is my actually new underscore grid. This is my new grid. And in this new grid, I'm going to use actual grid search CV. And we saw what are the arguments. We have the estimator and we have the parameter grid. Can you see this is the parameter grid which I've created, and grid parameter grid is nothing but a data frame. It has got one SVC column and it has got SVC margin over there. So what is the estimator in our case? Grid search CV, our estimator is model which we created here, this one in the pipeline. And what's going to be our parameter grid? So shift tab, you can see that there is a parameter grid out here. I can expand the plus sign and it's going to give me all the options. So I'm just going to fill two arguments, estimator and parameter grid. And my parameter grid is nothing but it's just grid. Now the thing which I'm going to write next, okay, it is running fine. The thing which I'm going to write next is actually I would want to fit my training data set to this grid. So once I fit this into the grid, I'm able to basically predict. Grid search validation technique and I've used here. But unfortunately, as I said, grid search I have not covered. It is my personal favorite topic in machine learning using sklearn, because grid search is a part of sklearn. So probably is definitely, if I'm finding time, I will explain you with examples. So new grid, we have the grid search model. We have loaded the model here, and then we have the new grid. So this is the model, but we want to actually train this model, okay? So I'm going to say, you give me new underscore grid dot. Can I fit this? Yes, I would want to fit this. And based on my X train, which is my X training data, and Y train, which is the dependent data over there. And what I want to do from this grid, basically, I want to get the best parameters. So let me run this new grid, and let's see what options do we have in that. Invalid parameter, SVC mar for estimator pipeline. Okay, did I write something with that? I've created the grid here with the dictionary and 2 columns and some values. And then I'm going to create a new grid, which is going to be the search mode for the model and the grid. And then I'm going to fit this grid using my X train and Y train. Yeah, that's correct. So let me run this again. Okay, it is still an error. SVC underscore mar, line number 236. No, this is fine. So I'm going to comment this. Let's run this. Okay. So we've got new grid and then grid search CV model and the grid. Yes. And then the new grid fit I'm doing. This is the new grid. So we just go here and see, okay, this is working. And then new grid. I want to fit this, which is correct. I'm using the X train and the Y train. Then, so the problem is actually in the fitting. So it's not able to fit the X train and the Y train. So So phase data, phase target, random state. Let me change this random state to some value, let's say 42. Run this. No. With an estimator dot get param. Okay. So let me switch to the workbook, the previous workbook, because I have already used this code there. So I've made some changes. Okay. So I've made some changes. So this is the grid. So let me just copy this. I've not used this print grid parameters because we haven't done that part. And let me go and try to paste this here just to save time. And here, and from sklearn model grid set CV, param grid is this one. Grid is a model, and the param grid. X train is here, Y train is here, and then the print. Let's see. So yeah, this is working now. Something is wrong in this code. I've used some different variable names. So this is going to work. And what exactly this will do is this ampersand time is a magic function in Python, which is just going to give me the time, how much time it actually took this grid to train on these variables which we have. So it's going to also display the time which it has taken basically to run this or fit this model. Now, I'm sure for some guys, this might not be so exciting and thrilling because, grid search is something which you don't know what's happening. You might not know what is SVC gamma over here. And I completely understand that point because we have to spend more time on understanding cross validations, model selections in sklearn, grid search method in sklearn, regularization in sklearn. And also the learning curves. We have also not seen the learning curves in machine learning. So because if you're training the model, then what is the learning rate at which the model has learned? All these things are very important in machine learning. So definitely, I couldn't club everything into this small session, but moving forward, I will definitely cover all those points, especially pipelines, creating learning curves, regularization, model validation using grid search methods. All these things are very, very essential. If for any technical company interview, people are not going to ask you about, seldom questions might come like, how do you clean the data? But basically they're going to give you a scenario rather than picking these small, simple questions. So they might not ask you what is the PCA. They might just ask you to give an example or a scenario basically on a PCA. In fact, moving forward, I have some plans like only to run you through the quiz and run you through only through the assignments, small assignments like a stockbroker wants to compare the portfolio of different stocks which he or she has and would like to actually create a cluster based on that. Other examples like whether a bank wishes to give loans to people based on certain parameters. Basic things like on classification, like logistic regression. What is the probability of a person engaging in in a crime based on certain factors like education and poverty, etc. How do we predict basically the traffic size on a particular day? So all these things basically are very, very important. And if we do this practically, then you'll be able to relate. Okay, we did the traffic analysis using X model. So definitely that model is being used for this. So just like we use Gaussian Bayes for our iris. So now you know that what kind of data sets we can apply Gaussian Bayes. You had also seen on what set of data sets we can apply logistic regression. But what is happening is, because the topics are too vast, I'm not able to spend a lot of time in it on a specific topic. So let's say logistic regression. I actually want to spend like maybe a couple of hours on logistic regression. In fact, more than that, and then fire you with a lot of questions on logistic regression, which is basically going to cover all the permutations of what logistic regression is. So yeah, so in all the sessions, I have this commitment to you, and moving forward also, I will try to maintain the commitment and try to demonstrate you with things. So yes, this now if you see that this is going to really, it is really taking a long time. So let's see how much time it will take. Earlier, before the class, when I tested writing this code, it took almost 4.5 minutes for me, but it seems like it is more than that now. So guys, you can ignore this code which we had earlier, and you can start writing this one and run the code and see what is the output. Actually, it seems that I have taken a lot of images out here in the X train and Y train. Here we've got a lot of images um, in this data set. So it's really taking a long time. In fact, I can also plot the learning curves, which is very essential. But right now, let this model finish. That is just the variables. I got an error. So let me load this code. You can simply directly copy this. Ensure that your variables are all fine. Okay, I've sent it to you. So ensure that all variables are in place. I mean, you have named all the variables properly. Naveen says I got an error. I mean, did you run this? Did you run this SK model selection? Anand say restarted the kernel and run all worked for me. Perfect. Guys, I'm not expecting this model to basically run for so long. I've tested it took almost 4 minutes, 4.5 minutes earlier. Right now it's taking too long. So can anyone tell me if it has successfully run at your end? Arvind, we have used the ampersand time so that once the model finishes the training, it will print the time it took actually. Yes, machine learning usually takes this long if you have a long data with you with a lot of features, because if you see, we already had 3,000 features and that was significantly reduced. But yes, if you have a lot of features. So Shittis says completed in 4 minutes. Shreyansh, the code must have given some warning on the deprecation part. Sankara says, I'm confused to understand each part. That is correct, Sankara. I understand that part of yours. So for people which has worked for 4 minutes, so that is correct, Wasim. That's the reason you might understand that why the big data and machine learning goes hand in hand. Okay, so when big data machine learning goes hand in hand, that's the reason, because if we have a huge amount of data in terabytes, which needs to for which we need training on. Um, Nisha says, I'm still getting an error. No, Nisha, we are beyond the error now. So I have pasted the code. You can use that one to run this, but ensure that you have all the variables in place. Okay, so what we're going to do is code when pasted, getting this error. Grids.cv object has no attribute best param. Grids.cv, no parameter best underscore param. No, that's not possible. This has to be there. Are you using the cloud notebook, Rohan and Naveen? Are you using the Blob City cloud notebook? My Yeah, Rohan, my question to Rohan and Naveen. So if Rohan is not using the Blob City, see, this is because of the deprecation which might have on your PC. So best params might not be there on the research CV for you. Nisha says, yeah, it's done. Okay, great. How much time did it take? Did you write the percentage time? So people, if you want to make the best use of this training, then Mahesh and Rohan and uh, you can use the Blob City notebook. Any issues in using the Blob City notebook? Arvind says done. I3 process is good for data science. Sujit, you also I'm already using Jupyter. So if you're using Jupyter notebook, Sujit, you should not have any issues. Saptashri says yes, done. 5 minutes. Not able to use sklearn on Blob City. Mahesh says I'm not, unable to use sklearn. It's not possible, Mahesh, because we all are using the same kernel. Bharti says done. What's the difference between grid search and randomized search? That's again basically a technique. What it is meant, it was just a naming error. Randomized PCA is not defined. That is because this error even I got before because of the incorrect uh, conventions in the library. Can we give any values in param grid? Param grid is already an argument. Yes, so which we have given SVC and SVC gamma. So yes, two variables. We have already given two values in the param grid. All right, so this is still running for me. So it seems like I will have to restart the kernel and let this running. No module name sklearn. No, sorry. You'll have to get that sklearn. Mahesh says error on Blob City. No, it's not possible, Mahesh. It's working for all of us. Sujit says import error, sklearn.datasets, import fetch people. There is a syntax error, Sujit. Please check that. The Python image library is required to load data from JPEG files. Yes, you can do that, Bhavnish. Himanshu, we need to import sklearn library. Yes, Ritu says value error. Still fitting. That's correct, Luigi. Is still fitting for me as well. Um, param grid means iterations. Mridu says done in 1 minute, 57 seconds. So the wall time, 1 minute 57 seconds. So let me just switch to the previous code because this notebook is still running. Estimator is basically your predicted values. Okay, so I'm coming to this old notebook because this notebook is still running for me and I don't wish to kill it and rerun it. So I have already prepared this here because I know this is Python and machine learning, so we should always have backups with us. So this is basically I had run before the class, and if you see, it just took 4 minutes 17 seconds for basically for this thing to run. A wall time is how much time did it take for the model to run. And if you see, the best chosen parameters from the grid search is parameter number 10 and the associated gamma value of 0.001. Now, what is this? As I said, that this is basically the grid of the image, the corners, which I was talking about. So the best feature it actually got was on the grid number 10, in the position and the corresponding gamma value of 0.001. So because what happens, we have color variations in the images, right? So some images might be dark and some might be basically a lighter version over there. So in order to avoid any pre-processing like standardizing the image, we have just used this parameter grid method over there. Okay, so let me please move forward because in next 10 to 15 minutes, I have to explain this model to you. So somehow we are able to get the CPU time. We are able to fit the model. Okay. Now what is happening when we have fit the model using grid.fit? Okay, this is basically our fit model. We want to get the best estimator from that, and also we want to predict on that value. So the model is actually this one, which is the best estimator, which we are going to use moving forward. So this is the best estimator which we have got it from the previous code. And again, the code which I've written here, I mean, you can just ignore it as I've said yesterday, because this is again to render the images. The only difference in this one compared to the previous one is, can you see the X test, which is actually the test data set which we are running, and basically the compared with the Y-fit. Y-fit is nothing but this one, which is actually the predicted values of X test, right? So X test, you print X test, which is this one. So you can see that this image of these people are actually X test for me. And I'm giving a Y label. In fact, the last session, this code was not working due to the syntax error, but this time it is working. So, and the Y label for the faces, which is actually the predicted values. So if I'm saying if the predicted value is equal to my actual value, then you give black, otherwise you give red, okay? So let me just show you the image. So assume that we have fit the model and we basically predict using this model. And what is the code that we have used for prediction? Oh, what is the code we have used for prediction? Is this one. So simply model.predict, which we have been doing always, and predict using the X test data. So we created X train, Y train, X test, and Y test. So we're going to use X test against the Y test. So you could see the model is fairly, predicted well. So the only difference is that the image of the bush, is misclassified into the Blair. So some of the images of bush has been misclassified as Blair. So Tony Blair, I guess. So if you look at now we will look at some of the classification report. So we are saying from the metrics, either you import accuracy score, either we import classification. So in this, we are doing a classification report. I'm saying you first give me the Y test, Y fit, and the target names for actually the target names for the faces. So this is the output. I remember in the first session, some of the people were asking about the F1 score and the recall and the support and the precision. Okay, so so precision, everyone knows what it is. Support, everyone knows what it is. F1 score, you can take that as an F statistics, which we have in linear regression. And this is a score between 0 and 1. So higher the score, the better it is. So, so you would see that we have a lowest score for Ariel Sharon. F1 score is the lowest, and the highest score is for Tony Blair. Okay. And if you look at the confusion matrix, so what I'm going to do, guys, let me just, for people who were successfully able to run the code, this fit code, you can take this one to create your model. I'm sorry, I generally don't copy and paste, but okay, use this one, send to all. This is the code to actually fit the model. And do not forget to use the best estimator, because this is what we want. We have got it from here. Because we have used the grid search method. So that is something which we need. Okay, and let me paste the second code. I'll just put that into the chat box. Please use this. So I have pasted two codes. One is after fitting the model, we have using the predicting the model. So this code is actually for predicting using our created model. And this is basically to plot the predictions with actuals. So I've pasted both these codes, so you should be able to render that. My third code here, which is for classification, so you can use this to get the classification report and to check the F1 scores. Okay, and so we have almost, and then finally we have the confusion matrix. There's one thing to observe. I will just show you the differences between. Okay, so let's copy this and let's scroll. Oh, really? And let's go here. So I've pasted all the code, so you should be able to run that. Confusion matrix and the classification report. Okay, so now we have the confusion matrix and the classification report. What I want to show the difference in these two is wherever we have the F1 score as high, you could see that for this Japanese guy, for Koizumi, the F1 score is 0.96, which is highest among all. Okay, and the lowest score what we have achieved is basically for Donald Rumsfeld. So this guy, so Donald, let's see what is the classification accuracy for Donald. Okay, let's go here. You would see for Donald that out of whatever 30, 34, and 35, out of 35 observations for Donald, which we have in the model, only 26 were actually classified correctly. So the Donald Rumsfeld with Donald Rumsfeld was only 26. And rest of the items or the images for the Donald is being misclassified into other characters, into other public figures. So since Donald had less F1 score, there is more of a misclassification over there. Let's see for the score, which is high, the one for Koizumi, 0.96, F1 score is high. So if you go for Koizumi, you would see that out of 13, only one was misclassified and 12 was correctly classified over there. What about the George Bush? So whatever items we had for George, um, exactly 105 were classified correctly and the rest were misclassified. One of the images of George Bush, we saw that it was misclassified as Tony Blair. And if you see, there is one out here. So definitely this F1 score is giving us, a better answer to what character basically, or what kind of data basically is completely, relevant with actuals and predicted. So this is the final step after the confusion matrix. Once we have the confusion matrix, we have done with our model. There's no further code which I've written. So this is the final step, and I would say that okay, this model is fairly done well, but it would do much better if we add this with more data. So for one particular image, we might have 50 or 100 observations, but we probably need more. I'm coming back to the question part. So Midhu says, please show me the code. Midhu, I've pasted the code, so you can copy it in case if you want me to repaste it. Arun says, my model is still being trained. I think, Arun, there is a problem. If you see my notebook, day 4, that is also still being trained. So you can kill the kernel and you can try to restart it over there. Nearly 10 minutes, I restarted the kernel. Show the confusion matrix code. Okay, is that code which I didn't really paste? Okay, no problem. I'll just Control A, Control C, and Control V. In case I've just pasted the confusion matrix code also. Siska says, can we study decision trees? Yes, Siska, will definitely do that. Image classified comes in deep learning. Kunal says, is image classified comes in deep learning? Basically, Kunal, that's the reason now this is a good way that I have demonstrated. Now the kernel is continuously working, okay, if you see, with just few sample images which we have taken, and we have not taken even the real life images. If we start taking real life images like, pictures of satellites or pictures of Earth, or if you want to detect something, face recognition in a crowd or something like that, then we will use deep learning, because deep learning is more sophisticated framework like using TensorFlow or Keras, especially built for deep learning. Because it gives more features, it gives more flexibility and scalability, and the computation on those AI part, deep learning is basically much faster. One of the advantages of using deep learning compared with machine learning, that deep learning is actually extracting the features by itself. So in TensorFlow and Keras, we don't have to basically write the code to basically extract the best features. That is happening automatically. And if you see in through the machine learning way, if we're trying to do with images, it is taking a real long time. For images data, it is always recommended to use a GPU. Not sure if you're using a GPU. No doubt that Blobcity has GPU instance, but we have not told this workbook basically to use a GPU instance. We are just using a CPU. So maybe when we switch this to a GPU, we should see the boost in performance. I have repasted the code for, okay, we wanted to repaste the code. Okay, I have repasted the code for confusion matrix. Shiptish, can you paste the code for your accuracy so that others can also validate? Can you paste your code for model accuracy? Model took about 14 minutes. Avinash, maybe it's this way that a lot of people have fired the server in just one go, so it has become a bit slow. Yes, deep learning is better than traditional ML, but deep learning is more for AI. Okay. Can you please show the code for face fetch? I'll do that. Face fetch. Can you please show this one? Okay. This one. Himanshu, I didn't get the question. SVM chooses data set based on importance or any other factor. I didn't get that part, Himanshu. Um, Shubham says Blob City provides deep learning. Yes, definitely. Shubham, Blob City has deep learning courses. And Nilesh, the grid object which we used to fit the model was a dict. That is correct, Nilesh. That was a dictionary. Luigi says still fitting. Yes, it's still fitting for me also. It's still fitting. I'm getting errors since grid search line. Rohan, I would recommend you to use the Blob City notebook. We have an option to limit the data set, Himanshu. Yes, I'll do that, Pratibha. I'll paste the code in the drive. How we use our images in ML algorithm. I just showed you that. See, images are nothing but they are multi-dimensional arrays. In fact, they are two-dimensional arrays, arrays of numbers, and then we can compute that. So let's say if you have a matrix of, so when you, if I import two images in the data, I've got matrix, like which I showed it to you in the code. So when we have two matrix, and now I can actually compare these two matrices for differences, for variances. If the variance is too high, then the image is basically too distinct. If the variance is not high, or maybe it's not there at all, then the images are very similar. Can you share the presentation? Yes. Anand Kumar, yes, I'll do that. Can you please show the code for fitting the model? I'm getting error saying that fit is not attribute of a date. Let me show you the code for fitting. This is the code for fitting. Yes, we'll put all the codes in OneDrive, Pratibha. Why only 8 target names are displaying in this sheet? Okay. Can SVM be used for text analysis? Yes, Mridu, we can use that. We can use it for categorization. So SVM is used for classification. So we can use a categorical classification, image classification, digit classification, or any other classification like text. So yesterday we used the multinomial name base for text classification. Probably we can also use SVM for that. Um, where have you shared that PPT? Okay, please suggest some books. How to create our own data set. When to use randomized search CV. I cannot see the clear heat map. It's all messed up. For the confusion matrix, so the code is there. Did you try to run the code for the confusion matrix? I'm using a plot, which is an SNS plot, SNS.heatmap. You can just snip this image. This image cannot be copied to paste into a Word document. So um, you can just basically copy that image and paste it into Word. Okay, I'm not sure if I have pasted this code. So yeah, so you can take this. This is actually for classification report. And then this is something for our metrics, but you can ignore this if you want to right now because we are simply going with confusion matrix. No doubt, the F1 score, the recall and precision are very important metrics in the overall learning process. Okay, heat map and confusion matrix. Pratibha, I have explained the heat map and confusion matrix. Basically, it is giving us the the count of correctly classified and misclassified. Now, the difference in heat map and confusion matrix, we are simply representing confusion matrix inside a heat map. We're using that tabular confusion matrix inside a heat map. So heat map is if the values are high, it's going to give color of red. If the values are low, then it's going to give you color of green. Sorry, blue in this case. Because we have used the transpose because we want to actually transpose the matrix which we have got it from the confusion matrix. So we are using a transpose to twist, basically pivot the matrix which we have for the labels. No, confusion matrix should not be messed up. I mean, if you have written this code the way it is, um, heat map and not true, you must have forgotten these arguments. These arguments are very important. So you can see the square and not the format. Here, that is the digits. And the C bar, it's okay. You can ignore the C bar. But yes, these three arguments are important. If you have ignored that, then your confusion matrix the heat map might look a little C. Can you try to correct that, Nisha? So going back to my new model, I am still this model is still fitting. So probably I will have to, kill this notebook and restart for the fitting out here. Oh yes, I completely forgot that about that. Sure, guys. So let's break for lunch and we can come back.
Yes, absolutely. Yes, thank you so much, Suveer. We'll take a quick break for lunch, 90 minutes, less than 90 minutes now. So 2:30 p.m. we'll resume again. It's the same link. Until then, just one quick announcement to make. Our lucky draw is still active. We will be announcing the results for the lucky draw just before ending the next session. So if you're looking to participate, now is the time. So you can quickly just post about it. You have to follow us on LinkedIn, find us on LinkedIn, follow us, write about how you like this training, and you might just be the lucky one to qualify into the lucky draw. So one person, one of you, one attendee will get 1 year free membership of Blobcity AI Cloud. That includes all our live trainings, our $25 plan, which allows you 3 cloud books. It also enables internet access on the notebooks. It gives you Jupyter Labs support, so you can use the Jupyter Labs interface of the notebook, and you can use this completely free, no obligations for 1 full year. So do post it. This is only on LinkedIn, so find us. You can scan the QR code that we are showing right now, or you can just go to the company URL, find us. You must follow us. You can post about us on LinkedIn. I attended the machine learning using Python course, and whatever, you can write whatever you like after that. Hopefully you'll have positive things to write about, but that's not the restriction. You can write negative things and post too. You still qualify. Just do not forget us to mark. Do not forget to mark hash velocity, else we won't be able to find your post. So if you've not done this yet, please go ahead and do this. We'll be announcing the lucky draw winners before the next session ends. Thank you so much. We'll break for lunch now, and we'll connect again at 2:30 p.m. India time.